All right, so let's go ahead and start with the second workshop. Second workshop that we're going to be doing on covering topics from algebra. Okay, so right now we're going to cover chapter 1.6 on algebra. This is going to talk about the rules of exponents or the rules of expressions that contain exponents. How we're going to simplify this. Okay, so let's go ahead and start with the first set of problems. And the first rule for simplifying exponents is called the product rule. Okay, and the product rule says that when I'm multiplying two variables, or it can be just two numbers also. Okay, but when I'm multiplying two variables that have exponents, I have to add those two exponents. Okay, so for example, in this scenario over here, I have a multiplication of two variables. So that means that I have to add those two exponents, and that's going to be my result. Okay, so remember that if a letter doesn't have an exponent, we have to assume there is a number 1 in there. Okay, so if I follow the product rule, which is multiplication of variables, I'm going to keep the base the same, so that's going to remain an x. And what I'm going to do is I'm going to add those two exponents, right? Exponent on the first x and the exponent on the second x. So this result is going to be x to the power of 11. Okay, so when you multiply variables, you have to add those exponents up. That's the first rule. Okay, we're still going to be doing some of the product rule. Okay, again, right, we have another multiplication of variables. The first exponent that I have there, that is a 1. Okay, so 1 is an exponent. I have an 11 on the second variable. So what this means is that the base is going to remain the same, the big letter. Okay, and then I have to add those two exponents. So the result of this multiplication will be x to the power of 12. Okay, x to the power of 12. So something like this. Let's see, why is that my... Okay. I will go ahead and use that color. Okay, multiplication of variables means addition of exponents. Multiplication of variables means addition of exponents. Okay. For this other example, you're gonna see the trend right now. Okay, so we're multiplying two variables. If the variable doesn't have an exponent, we have to assume that's a number 1. And all I'm going to do is add the exponents. So 1 plus 12, that's 13. Okay, x to the power of 13. And the same is going to happen if the base is any number. So for example, if I have something like a to the power of 3 times a to the power of 5, I am going to keep the base. I'm not going to multiply 8 times 8. Okay, I'm going to keep the base, and all I'm going to do is add the exponents. Okay, so that's how I'm going to get this answer over here. Okay, so it can be a letter like the x's, or it can be an x like a variable, it can be a number like the 8. It doesn't matter. It can also be an expression. It's going to be the same thing. Okay, let me keep going on this same product rule, since we have several rules that we're going to do. Okay, multiplication of variables means addition of exponents. So I have two x's, and this only works when the base is the same. They're both x's, or they're both y's, or they're both 9s, or they're both 8s. Then this rule applies. Okay, so rule says I will have to add up exponents. 4 plus 6, and 4 plus 6 is 10. So that will be my answer. Now you have to be careful. Okay, so this is it doesn't matter if it's a positive or a negative number, you have to add them up. Okay, add them up. 4 and 6, 10. That should give me my answer. Okay, again, the product rule. X to the power of 4 times x to the power of 7. That means x to the power of adding the exponents. So this should be x to the power of 11. Okay. Multiplication of variables means addition of exponents. X to the power of 4 times x to the power of 8 means x to the power of 4 plus 8, which is x to the power of 12. These are really, really simple expressions, but we are trying to understand the product rule. Okay, the rule of the products. So what happens when I'm multiplying two variables? Okay, again, what are we going to do here? 8 plus 4 on the exponents This is because we're multiplying x times x. So x to the power of 12. Isn't that the same one as the one before? Yeah. Okay, x to the power of 12. You're going to see the trend here, x to the power of 8 plus 6. And 8 plus 6 is x to the power of 14. Okay, all I'm doing is adding the exponents. That's a product rule. Okay, product rule, x to the power of 9 plus 2. X to the power of 11, adding up those exponents. Remember that this meeting is being recorded, so anything that you see here on the screen and that you hear, you can always go back and take a look at all of those examples, or maybe take notes. Okay, so you don't have to be rushing, writing everything super fast. You can just take your time to understand the concept, and then later on you'll go back and take your notes. Okay, so anytime, just raise your hand. Okay. Is it going to make a difference that I have a different letter in here? Everything has to be the same. We have to assume there's a number 1 when there's no exponent. Okay, and now I go ahead and do the multiplication of variables, which is 1 plus 3, adding the exponents to y to the power of 4. Okay, so that's going to be the first rule, the product rule. The multiplication of variables translates into addition of exponents, or adding exponents. Okay. Let me go ahead and open the second worksheet for the second rule. Okay. Now the next rule is called the quotient rule. This is the opposite of the product rule. Okay. Quotient rule says if you are dividing variables, let's say that's the same variable x. If you are dividing those, then you have to subtract exponents. Okay. So always take the top exponent on the number on the top, and subtract it, or subtract the one in the bottom from the top, right? On this case, the result is going to be x because that's the variable. I'm going to take the exponent on the top, 11, and I'm going to subtract the exponent on the bottom. Okay, that's going to be my process. Top minus bottom, top minus bottom. Okay, so 11 minus 3 is going to be x to the power of 8. Okay, kind of the opposite of the product rule, the quotient rule. Division of variables means subtract top minus bottom. Okay, so that result should be x to the power of 8. Let's keep looking at the division of variables. Okay, we are not dividing those numbers. Be careful. Okay, you're dividing x over x, as in x to the power of whatever exponent you want to put in there, divided by another x with another exponent. The result is going to be x, and you just have to subtract those exponents. Okay, so 10 minus 2 is going to be 8. This is also x to the power of 8. Okay, because 10 minus 2. Okay. Pretty sure you're going to take a guess of what this is going to be, right? You see the trend? X, 13 minus 5. That's also x to the power of 8. Okay. Top exponent minus bottom exponent. X to the power of 8. Okay, same thing. It is really tempting. It is really tempting to do the division of 15 over 3. Those are not coefficients or big numbers. Okay, so you have to do the rules of exponents like we've been doing. And in this case, if we are dividing x's, that means that we have to subtract exponents again. Okay, so 15 minus 3, that is x to the power of 12. Now, when you have big numbers, again, when you have coefficients like the negative 12 and the positive 6, those are big numbers. Those don't go on the rules of exponents. Okay, even if you're multiplying those big numbers also. Okay, on this case, you have to divide those numbers normally, like a normal division. They're big numbers. They don't follow these rules. It is the 11 and the 4, the ones that are going to follow these rules that we're talking about, because those are exponents. Okay, but for the big numbers, the coefficients, negative 12 divided by 6, that's just going to be a normal division. And negative 12 divided by 6 is the division of a negative and a positive. So the result is going to be negative. And 12 divided by 6 is 2. And then I'm going to apply the rules of exponents to this x's that I have in here. It's x divided by x. That means it's also going to be x and the exponent in the top, 11, minus the exponent in the bottom, which is 4. So this result should be, I'm going to leave the negative 2 there, then x to the power of 11 minus 4. Okay, 11 minus 4 should be 7. Okay, that's the result. That's the answer that I'm looking for. Over here looks like C is the answer. Okay, so big numbers, they behave normally in all of these operations that we're doing. If they're adding, they're adding. If they're multiplying as normal multiplications. It is exponents that follow these rules that we're talking about. Okay, again, division of variables means subtraction of exponents, and in this case I have x's and I have y's, so you just take those separate or like individual operations. Okay, I'm going to go ahead and divide the x's first. So that is x to the power of top minus bottom, 10 minus 4. And then I'm going to take the y's, y to the power of top minus bottom. So y to the power of 6 minus 3. Okay, top minus bottom. So that translates into x to the power of 6, y to the power of 3. So x to the power of 6, y to the power of 3. Okay. Again, division of an expression that has same variables on the top and the bottom, or at least one of the variables on the top is also on the bottom. So we can go ahead and do the division. Okay, those numbers, we are not dividing those numbers. Remember that this is the division of x's and they have their exponents, right? So I have to do a subtraction, top minus bottom. So x to the power of 12 minus 6. Those are going to be these x's over here. And then if I divide the y's, y to the power of 12 minus 6. Okay, so this is going to be x to the power of 6, y to the power of 6. Okay, 12 minus 6. So where's the, this should be my answer over here. Okay, I don't know if it's showing or not. It should be there. Okay, again, division means subtraction of exponents. I have the x's in here. I'm going to go ahead and divide the x's. So x divided by x is x. I have to subtract the exponents. Okay, 13 minus 7. And then I'm going to do the same thing for the y's. So 11 minus 5. And just go ahead and complete the math. X to the power of 13 minus 7 should be 6. And y to the power of, excuse me, it should be, yeah, this should be 6. And 11 minus 5, that should also be 6. Okay, so that should be my final result. X to the power of 6, y to the power of 6. I think that one is over here. Okay. Keeping up with the expressions. Okay. 16x to the power of 12. Y to the power of 12 divided by 4x squared, y to the power of 6. Okay, again, numbers, normal numbers, are just going to divide normally. Okay, the 16 divided by 4, that's a normal division. So 16 divided by 4, that is 4. Okay, I'm not subtracting because it's a normal division. It is when I have variables that have exponents that I'm going to do that subtraction of exponents. Okay, so top minus bottom, 12 minus 2. And the same for the y's. Y to the power of 12 minus 6. It should be 4. X to the power of 12 minus 2. Y to the power of 12 minus 6. Okay, so what's the answer? It's like B is the answer in this case. Okay. Last one for the second rule. Okay, last one for the second rule. We're doing a division. 40 divided by 8. 40 divided by 8, that's going to be 5. Okay, the division of the numbers. Okay, normal division. Let's go ahead and divide the x's. Dividing x's means subtract exponents. And dividing y's means subtract exponents. 13 minus 4, that's going to be 9. And 13 minus 5, that should be 8. Okay. So this should be my result. So up to now we have two rules. The product rule means when you multiply variables, you have to add the exponents. And the quotient rule, which is when you divide variables, you have to subtract top minus bottom. Okay. Those are two rules. The third rule is called the zero exponent rule. Okay, and my zero exponent rule says that if my exponent is 0, then the expression cancels out. Okay, and it cancels out as a 1. Let me show you what I mean in this case. Okay, so I have an expression, and it can be a letter, it can be a number, it can be anything, but if the whole thing is to the power of 0, that means it's going to cancel out. Okay, when we say cancel out, it means that it becomes 1. Okay, number 1, I'm multiplying 1, I'm dividing 1, you know, a 1 that not through addition, it doesn't cancel out through addition because that will become 0. Okay, but it cancels out through multiplication. Okay, so anything to the power of 0, that's the third rule. Anything to the power of 0 is going to be equal to 1. Okay, anything to the power of 0. It can be a number, it can be a letter, it can be an expression, it can be, you know, a bunch of parentheses. As long as everything is to the power of 0, then it should be equal to 1. Okay, so -5, all of it, the parentheses, everything's to the power of 0. That means it cancels out to a 1. Okay, so my answer is 1. Now I have to be careful. Only whatever is in front of the exponent cancels out. In these two cases, we don't have any trouble because in front of the exponent is a parenthesis, so everything inside the parenthesis just cancels out. Okay, but it might be a problem when we reach examples that don't have parentheses like this one. Okay, so when we don't have a parenthesis, you have to be careful because the exponent is going to cancel out only whatever's in front of it. And in this case, only the 4 is in front of it, not the negative sign. Okay, what this means is that I am going to cancel out the 4 with the exponent, and I'm going to have a negative sign as a leftover. Okay, of course, anything that cancels out equals to 1. So if I give it a negative sign, it's a negative sign that I have in front of you, the result should be -1. Okay, so that is the difference between having a parenthesis and not having a parenthesis. So take a look at the previous example, or the one that we didn't do this, I just skip it, right? But in this case, that exponent is applied to everything. In this case, I have that parenthesis, so that 0 belongs to everything inside the parenthesis, means everything inside the parenthesis cancels out, or everything inside the parenthesis becomes 1. Okay, so in this case, the result should be 1. Okay, if there's no parentheses, then it only cancels out the number or the letter that's in front of it, not the signs or not any other numbers. On this case, okay, -5 to the power of 0, as I already mentioned, 0 cancels out only whatever's in front of it. In this case, only the 5 is in front of it, only that is going to cancel out. I still have to carry over my negative sign or the number or whatever else I have left in there. Okay, and if something cancels out, that's a 1. Okay, so in this case, the result should be -1. Again, zero exponent rule. So we have two options in here. It's either -1 or 1, right? So the exponent is going to cancel out. Just the number that's in front of it cancels out. The negative sign carries over. And since something cancels out, the result means 1. Okay. Result is 1. Difference between having a parenthesis and not having a parenthesis. On this case, I have a letter, a number and a letter inside the parenthesis, and I have an exponent of 0. Is that going to be an issue? No. The third rule, or the zero exponent rule, says that if anything is to the power of 0, it's going to cancel out. It can be as crazy as you can think. Okay, it can be a bunch of letters or a bunch of numbers or negatives or positives or fractions or roots or, you know, as complicated as you want. If it has an exponent of 0, it just cancels out to 1. Okay, cancels out to 1, but only whatever's in front of it. In this case, since that's a parenthesis, that's in front of it, everything inside the parenthesis just cancels out. Okay. Same thing is going to happen here. Okay. Everything is inside the parenthesis, and that parenthesis has an exponent of 0. Everything cancels out. Result is everything cancels out, the result is 1. When you have an exponent of 0, the result is 1. Okay. Everything cancels out, the result is 1. 9 to the power of 0, everything cancels out, the result is 1. Okay, anything that's to the power of 0. So up to now we have 3 rules. Okay, when we multiply variables, we have to add exponents. When we divide variables, we have to subtract top minus bottom. And when we have an exponent of 0, it's going to cancel out to a 1. Okay, but exponents, and not only this rule, but all the rules that we're going to talk about and all the rules that I already mentioned, is the same thing. Exponent only applies to whatever's in front of it. Okay, if it's a parenthesis, then it applies to everything. If there's no parenthesis, it only applies to the number or the letter that's in front of it. Okay, that's the third rule. Now, the fourth rule, it's called the negative exponent rule. Okay, the negative exponent rule is going to talk about reciprocals. What happens when I have a negative exponent? If you're simplifying an expression, the expression has to have all positive exponents, or else it's not going to be simplified. Okay, so the negative exponent rule says if I have a negative exponent, you can just send it to the other side of the fraction, and that's going to change the exponent to a positive. Okay, so in this case, in this scenario that I have here, I have 2 negative exponents. The one on the top is negative and the one on the bottom is negative. And you're gonna ask, why don't I just do the, the quotient rule, top minus bottom? Well, you cannot do this, that because those are different letters. The top is X and the bottom is Y. If they were both X's, then you can go ahead and do that, right? Top minus bottom. But in this case, there are different letters. You're not gonna be able to use these rules on those 2 variables together, but you're gonna use the rule 2 times. Okay, so one rule for the X's and then one rule for the Y's, and you should be good to go. Okay, so negative exponent rule again says if I have a negative exponent, or a variable with a negative exponent, I have to send it to the other side of the fraction, and it's going to become a positive exponent. Okay, so let me draw my fraction in here. I know my x to the power of 7 is negative, or it has a negative exponent. So in order to make it a positive, I'm going to send it to the bottom. That's going to turn it into x to the power of 7. Now it's positive. Everything else remains the same, right? Only that one becomes positive. Now the y is also a negative exponent, okay? And the rule says if I want to turn this into a positive exponent, I have to send it to the opposite side of the fraction. Right now it's on the bottom, so I'm going to send it to the top, okay? And if I send that to the top, then that exponent is going to become positive. So my answer right now, without any parentheses or any different x's, different y's around, this should be simplified. Okay. Also, I don't have any negative exponents, so I should be good to go. My answer should be y to the power of 7 divided by x to the power of 7. Okay. So the fourth rule says, again, you have a negative exponent, get the reciprocal. That's a little fancy way to say it. An easier way to think about it is just send it to the opposite side of the fraction. Okay, if you have it on the top, send it to the bottom. If you have it on the bottom, send it to the top, change the exponent to the opposite side. If you don't have a fraction, if it's just a bunch of letters or numbers in a row, then you create a fraction and then you start sending them down. Okay, so that should be the rule. Again, I have 2 negative exponents in this case. You might only have one exponent that's negative. That's fine. You just send one of them to the other side, right? The negative. But if you have 2 negative exponents, then both of those have to change sides. Okay, or go to the other side. So what I'm going to do here, the x, I'm going to draw my fraction. The x is a negative exponent, so that means it has to go to the bottom because it's originally in the top. Goes to the bottom and it changes to a positive exponent. And then the y is negative on the bottom. I have to send it to the top. And if I do that, then the exponent becomes positive. That's the only thing that changes. Okay, getting the reciprocal means change the sign of the exponent. This only applies, again, these are rules for exponents, only apply for exponents. Okay, so that should be my result. Y5 x4. Same thing. Okay, let me draw my fraction here. I have a negative exponent on the x. That means the x has to go down. Now it becomes positive. I have a negative exponent on the y. That means the y has to go up. Then it becomes positive. Okay, so y cubed divided by x cubed. Any negative exponent that you have, if it's a variable, if it's a number, it has to go to the other side, okay, to the opposite side. Now, this is a question that I like a lot, okay, and I think we have this on the class assignments. I have to get rid of the negative exponent, okay, or the variable or the number that has a negative exponent has to become a number with a positive exponent. Okay, before I even start doing any math, before I even start doing repeated multiplication on the two, before I start trying to calculate that exponent, you have to convert it into a positive exponent. Okay, so there's a negative exponent, -4. That means that I have to convert that into a positive. So the number that has the -4 as exponent is going to be the 2. And can you see why I am not taking the whole thing, right? Why am I not taking the whole thing? Because I don't have a parenthesis. That means that that exponent only applies to whatever is in front of it. And in this case, only the 2 is in front of it. Okay, so only the 2 with exponent of 4 is going to move up or down. Only that is going to be subject to change. Okay, that negative sign that I have in there has to remain at the bottom. If the problem was asking us to move that negative sign, this will be written something like this. And that means that the whole thing has an exponent of -4. The whole thing is going to become reciprocal. Okay, the whole thing is going to go to the other side. So that's not the case. Okay, those are different cases. So let's go ahead and send this number with a negative exponent to the other side of the equation, of the expression. So on the bottom, I'm going to send it to the top. Everything's going to remain the same, but my exponent is going to be positive now. And on the bottom, what is remaining on the bottom? I still have this negative sign that has to remain on the bottom. And you know, a floating negative sign or a negative sign by its own is the same thing as a -1. Okay. At this point, if you want to do penance or you want to evaluate the exponent, we haven't done this before because all we had were letters. So if it's x squared, it's just x squared and that's it, right? There's nothing else we can do. But in this case, 2 to the power 4, that's something that we can do. So we can simplify a little bit further. 2 times itself 4 times. So 2 times 2, that's 4. Times 2, that's 8. And times 2, that's 16. Okay. So 2 to the power 4, that's going to be 16. And on the bottom of my fraction, I have a -1. So dividing a positive by a negative number is going to give me a negative result. Okay, so the result is -16. Okay. Again, expression that has negative exponents mean get the reciprocal. Whatever has a negative exponent has to change sides. This guy is going to go to the bottom, become positive, and y to the power of -5 is going to go to the top, become positive. Okay, changing sides changes the sign of the exponent. y5, x6. Let's keep going. I have 3 variables in here. Okay. Remember that you're not going to combine those. Okay, they are different variables. You should end up with x, y, and z on your result. Okay, just exponents are going to be different. You know, they might have different signs, but you only remain with x, y, and z. Don't go ahead and combine those. Okay, so let's make the analysis. Now we have 3 choices. What are we going to move and what is going to stay where they are? Okay, x to the power of 8. That x to the power of 8 has to stay in the top because it doesn't have a negative exponent. That guy is not going to move. Okay, so anything that doesn't have a negative exponent is not applied to this rule. This is called the rule of negative exponents, right? So that x is going to stay in there because it doesn't have a negative sign. What about the y? Is the y going to move? Yes, it has a negative sign. It's already on the top of the fraction, so I have to send it to the other side, on the bottom. I'm going to send it to the bottom, and this y is going to become a positive exponent. Okay, if it has a negative exponent, it goes to the other side of the fraction. Okay, I have a z to the power of -3. that has to go to the other side of the fraction. It's on the bottom, it has to go to the top because it has a negative exponent, okay? So I'm going to send it to the top of my fraction. And now I have three variables with three positive exponents, which should be set for the next problem. Okay, so what could be the answer here? Looks like the last one is the answer. Okay, just as an option. And by the way, that's the only correct answer. Okay, all the other answers come from wrong approaches. Okay, so there's only one correct answer in all these problems. Okay, again, negative exponents mean get the reciprocal or send them to the other side of the fraction. Exponent of -7 has to go to the bottom, becomes positive. Exponent of -6 has to go to the top. So on the bottom has to be sent to the other side of the fraction. Okay, and that should be my result. Okay, y6 divided by x to the power of 7. Again, let's go ahead and do the negative exponent rule. Okay, negative exponent rules means you're going to create a fraction. Right now I don't have a fraction, but you can think about this as having everything divided by 1. And I know I'm going to have a fraction because I have a letter that has a negative exponent. And if there's no fraction, that means it's a numerator. So the top, it has to be sent to the bottom of the fraction. Okay, so right now I have three items that I'm going to be playing with. I have a number 4, I have an x, and I have a y. Can you see why I separated the 4 from the x? Because I don't have a parenthesis. So I know that -2 only applies to the x. It does not apply to the 4x. It applies to the x because it is in front of the x only. If I wanted that to apply to the 4 as well, it would look something like this. Then the whole thing has an exponent of -2. The whole thing can move up and down, depending on where you're sending this. Okay, so in this case, is that 4 going to stay on the top? Does that 4 have a negative exponent? And the answer is no, it doesn't have a negative exponent. It has no visible exponent in there. That's a number 1. Okay, so the 4 has to stay wherever it is. And in this case on the top, so I'm just going to leave it on the top. Okay, remember these are rules for exponents, and the exponents only apply to the number in front of it or the variable in front of it. In the case for the x, you're going to see that this x has to go to the bottom because it has a negative exponent. Change the sign of the exponent and then send it to the other side of the fraction. And then this y is y to the power of 8. I am not going to change the sides of this. That's already positive. I'm not going to send it to the other side. I have to keep it where it is. If it's on the top or bottom, you just keep it there. Okay, this is a rule for negative exponents. Okay, that should be my answer. 4y8 x squared. Again, an expression that has a negative exponent. Okay, so that means that I'm going to have a fraction. If I don't have a fraction already, I'm going to create a fraction. Okay, separate all the items. I'm separating the 3 from the x. Can you see why? I don't have a parenthesis. Okay, I don't have parenthesis. That means that x does not belong. That exponent does not belong to the 3. Okay. I see that. Okay, Rosa, you there? It's good. I don't have a speakers, so I'm not able to hear you. But if you want to say something, you can do the raise your hand action that's available here on Teams, or you can just type something in the chat so I can reply. Okay. I'm gonna keep going. As I was saying, I have 3 items. Okay, I have 3 items. The 3 does not belong to the exponent of -5 because there is no parenthesis in there. Okay, if there's no parenthesis there, then that exponent only applies to whatever's in front of it. That 3 is going to stay on the top. It doesn't have a negative exponent. I'm not going to move it. That x is going to go to the bottom. Has a negative exponent, so it's going to become a positive. Okay, and then this y to the power of 6, I'm not going to move this because this has a positive exponent. Okay, so I gotta stay in there, in the top. So that should be my final result. 3y to the power of 6 divided by x to the power of 5. Okay, 3y to the power of 6 divided by x to the power of 5. Okay, this is the fourth rule up to now. Okay, fourth rule, the negative exponent rule. In this case, now I have a number, it's the same thing. Okay, I have a number with a negative exponent. I have to create a fraction. So that is originally on the top, right? That is on the top. That means it has to move to the opposite side of the fraction. Okay, now it's going to go to the bottom of the fraction, and then it's going to become a positive exponent. Now, if that's the only thing that you have in the top of a fraction, then when it migrates, or when it goes to the other side, it looks like there's nothing left in there. But through multiplication, we have a number 1 left in there. Okay, it doesn't mean that I'm always changing this to the bottom and this to the top. Okay, it does not mean that. That's a different thing. Okay, but if the only thing that you have in there is just an expression, you know, you're moving that, you have to move that to the bottom of a fraction, then on the top you can just leave a number 1. Okay, a 1 as in a coefficient 1. If you simplify this, since this is no variable, it means that you can get the actual mathematical result 2 to the power of 4, right? 2 times itself 4 times, something like this. That should be 16. So my result is 1 over 16. Okay, so 2 to the power of negative 4, that means 1 over 2 to the power of 4. Okay, that way you get rid of the negative exponents. That's the fourth rule. A recap on the rules. If you multiply variables, you add exponents. If you divide variables, then you subtract top minus bottom. Anything to the power of 0 equals to 1 or cancels out. Okay, and if you have a negative exponent, then you move it to the other side of the fraction and it becomes a positive. Okay, becomes a positive exponent. Next rule, which I think is the last rule that we might encounter. Okay, it's called the power rule, and the power rule applies when you have 2 exponents. Okay, we haven't had any situation where we have a variable with an exponent and then we have an extra exponent in there. Okay, so the power rule says if you have exponent of exponent, 2 exponents together, you have to multiply those numbers. Okay, multiply those numbers, and then you can go ahead and keep simplifying the expression. Okay, so in this case, if I have one variable or one number that has 2 exponents, that is the same as multiplying the exponents. Okay, in this case, negative 2 times negative 5, that should be positive 10. And that is my new exponent on the variable or the number that I have in the bottom, or the expression that I have as a base. Okay, so 2 to the power of 10. That is my power rule or exponent of exponent rule. Okay. Let's see what this problem is going to be. So 2 to the power of 2 to the power of 5. I have one variable or one big number, 2 exponents, 2 small numbers on the top. That means that I'm going to keep the 2 and I have to multiply those 2 exponents. So 2 times 5. Okay. And then 2 times 5, that's going to be very, very simple. 2 to the power of 10. Okay. Now, again, the same thing. I'm going to go a little bit fast because I don't want to go over 3 p.m. Okay, so a variable with 2 exponents means multiplication of those exponents. Okay, so 6 times 5, that's going to be 30. Okay, variable with 2 exponents means multiply those exponents. Okay, so these exponents are 2 and 6. That means I take 2 times 6, multiply those, and that's going to be my result. And it can be, instead of a 3, it can be an x, it can be a y, it can be a z. Okay, remember that this meeting is being recorded, so you can always go back and take a look at the problems that you're having trouble with, or you can always go back and take more time on taking your notes. Okay, so I'm Let's keep this one. Something with a variable, okay? So x to the power of 2 to the power of -5. If we are simplifying this, that means x to the power of multiply exponents, okay? And that's going to be x to the power of 2 times -5, that's -10. And if it's asking to simplify the expression all the way until the end, then you cannot have negative exponents. We have a rule for negative exponents, which is get the reciprocal. Okay, convert it into a fraction. If it's on the top or by itself, then you send it to the bottom of a fraction. It becomes positive. This is the previous rule, right? The negative exponent rule. Okay, so most of the times when you multiply two exponents, if one of them has a negative sign, then you're going to end up with a negative exponent. You have to get the reciprocal. If it's in the bottom, then you have to send it to the top. If it's in the top, you send it to the bottom. Okay, so 1 over x to the power of 10. Again, same thing. I have two exponents, so that means multiply those exponents. And 4 times 8 is going to be 32. As a -32, I have to get the reciprocal. I have to get the reciprocal. I have to send this, which is a number with no fraction. I have to send it to the bottom of the fraction. So it becomes positive. If it's the only thing there, you can replace that for a 1. Okay. 1 over x to the power of 32. Super simple. When you have two exponents together, multiply them. Okay, 5 times 4. That's x to the power of 20. Two exponents together means multiplication. 4 times 8 or -4 times 8, that's going to be -32. And if you end up with a negative exponent, you send it to the other side of the fraction. Becomes a positive exponent. Okay, up to now, we have 5 rules. Okay, we have 5 rules. If you multiply variables, you have to add up the exponents. If you divide variables, you subtract. If you have an exponent of 0, cancels out. If you have a negative exponent, goes to the other side of the fraction. And if you have two exponents, you multiply those exponents. Okay. Now this is just like a variation of the powers rule. If you have several things inside the parentheses or several things that you're going to distribute an exponent to, then you have to do so. Okay. So in this case, if I have an exponent outside, it goes to the -2 and it also goes to the letter A. So it's like I'm having two separate operations in here. I have -2. That's my 4, right? And I'm distributing -2 to the power of 4 and A to the power of 4. So you give that exponent to every single thing that you have inside. This is called the powers rule, okay, or the products powers to products rule. So if you have an exponent outside the parentheses, that exponent goes to every single thing inside the parentheses. Okay, it's in essence the same thing as saying it applies to the parentheses, to what's in front of it, which is the parentheses. That means to every single thing that's inside the parentheses. Okay, so in this case, -2 to the power of 4, that's a -2, that's not an exponent. We don't have to get reciprocals of this. Okay, that's just a big number. And it's -2 times itself 4 times. So -2 times -2, that's +4, times -2, that's -8, times -2, that's +16, 8 to the power of 4. Okay, 16, 8 to the power of 4. Again, I have an exponent. I have several items inside the parentheses. It is going to be distributed to the -2, to the P, to the Q, and to the R, to every single thing that I have there. So first thing is -2 to the power of 4, P to the power of 4, Q to the power of 4, R to the power of 4. So everything gets that new exponent. And -2 to the power of 4, we already did, that's 16. P to the power of 4, Q to the power of 4, R to the power of 4. It looks like the first answer is the correct one. Okay. Let's distribute that exponent. So 5 goes into the -2 as an exponent. 5 goes into the X. And 5 goes into the Y. Okay. The -2 to the power of 5. If -2 to the power of 4, that is +16. +16 times -2, an extra multiplication. is negative 32. Okay, this comes from negative 2 to the power of 5, which comes from negative 2, negative 2, negative 2, negative 2, negative 2. Okay, so negative 32, x to the power of 5, y to the power of 5. This guy's over here. Okay. Let's see if I can have something with a little bit more complicated. Sure, why not? Okay. If you have an exponent outside the parentheses, this has to get distributed to every single thing inside the parentheses. Okay. So this exponent of negative 4 is going to go to the 2. That's 2 to the power of negative 4. It's also going to go to the x. It already has an exponent. Doesn't matter. Okay. You know how to deal with variables with two exponents. So second is x to the power of negative 8, and I'm giving it that new exponent, power of to the negative 4. Okay. The same is going to happen for the y. It already has an exponent, so be it. Okay, so be it. Give it an extra exponent. And then the negative 4 also goes to the z. Z already has an exponent, so be it. Okay, it gets an extra exponent. So that exponent got distributed to every single thing that I have inside the parentheses. Okay, so let me go ahead and simplify this. It's 2 to the power of negative 4. Why we have negative exponents? Okay, that's the last operation, right? That negative exponent has to go to the 2. I would rather convert that into, it's reciprocal to make that positive. So 1 over 2 to the power of 4, which ends up being 1 over 16. Okay, that's a 2 to the power of negative 4. Send it to the bottom. It becomes 2 to the power of 4 on the bottom. Okay, I'm going to do the product rule here, the power rule. Multiply those two exponents, negative 8 times negative 4. And that's going to be x to the power of 32. I don't have any more negative exponents, so we should be good. Okay. I'm going to do the same thing, multiply those. 3 times 4, that's going to be negative 12, since the negative 4 is negative, right? And over here, c to the power of negative 6 times negative 4, that's going to be positive 24. Now, this is all I have right now. Okay, all I have right now. I have to change whatever is a negative to the bottom of the fraction. Okay, so I already have a fraction in here. So pretty much everything that I have, it's in the top of the fractions. Everything that's in the bottom that I have moved to the other side of the fraction is the 16, right? So I have to decide if I have to move something else. Is something else have a negative exponent? And the answer is yes. So this guy over here has a negative exponent. It has to go to the other side of the fraction. It has to go to the bottom, and that way it becomes positive. Okay, so let me keep everything at the top. So x to the power of 32. This is top. Z to the power of 24. That's top. I'm not moving those because they don't have a negative exponent. Okay, and on the bottom I have 16. I originally have the 16 that I moved earlier, and now the y is going to be there as well. Okay, so everything moves. Everything with a negative exponent moves to the other side of the fraction. Okay, so that should be my answer. Something like this. 32, 24, 16y to the power of 12. Okay. Let me go to the last rule, which is pretty much the same rule as before. If you have an exponent outside of parentheses, it goes to everything on the top and everything on the bottom if you have a fraction. Okay, on the previous examples, everything was multiplying. Okay, so that exponent only goes, well, it goes to everything inside the parentheses, which happens to be just multiplying. Right now we have a division. The same thing, it goes equally to every single thing that I have in the parentheses. So in this case, or this new rule, the quotient rule, means that this exponent has to go to the x that already has an exponent, so be it. And it's also going to go to the y that I have in the bottom of the fraction that already has an exponent. It doesn't matter. Give it an extra exponent. Okay, it's same as the previous rule, but you're giving it to the top and then you give it to the bottom of the fraction equally. Okay, you know the power rule. Multiply those exponents. Negative 4 times negative 2, that's negative 8. Excuse me, positive 8. Positive 8. And on the bottom, I have y to the power of negative 8. Okay, 4 times negative 2. Okay, since I have a negative exponent, it means I have to send whatever has a negative exponent to the other side of the fraction. Okay, so this I'm going to send to the top of the fraction. The x to the power of 8, I'm going to leave it there because it doesn't have a negative exponent. That means I don't have to move it. But the y I'm going to move because it has a negative exponent. Now it becomes positive. Okay, so x8, y8. This should be my result over here. Okay. Again, same thing. I'm going to take this exponent and take it to every single thing that I have in there. Okay, x to the power of negative 4, given an extra exponent, divided by y to the power of 5, give it an extra exponent. Next rule, multiplication of those exponents is I have two exponents together. Negative 4 times negative 2, and 5 times negative 2, that's negative 10. Again, I have a negative exponent, means I have to send that to the other side of the fraction. X to the power of 8 stays. Y to the power of negative 10 now becomes a positive 10. Okay, change in size of the fraction means change the sign of the exponent. So this should be my answer. Let me see if I can get something a little bit something like this. Okay, p to the power of 2 divided by 3, and then I have an exponent of 3. That means this 3 goes to the p. I already have an exponent of 2. Give it an extra exponent, that's fine. And it's all divided by giving that exponent to the 3 as an exponent, okay? The 3, I already have it there, and I'm giving it an extra exponent of 3. Let's see where this takes us. I have a variable with 2 exponents, multiplication. 2 times 3, that's 6. And on the bottom, I have a number with an exponent. That's a mathematical operation, okay? So it's 3 times itself 3 times. So 3 times 3 times 3. That's a repeated multiplication. 3 times 3, 9 times 3 should be 27. Okay. So we're almost running out of time of the meeting. Okay. Let me go ahead and hit the last worksheet over here that has pretty much examples for all the rules. Okay. So let's go ahead and simplify this. We have all the rules, right? Multiplication means addition of exponent, division means subtract exponents. Okay, powers of 0 cancels out. Negative exponents go to the other side of the fraction. Okay, 2 exponents together, you multiply those. Okay, if you have a parenthesis and exponent, you distribute that to every single thing. If they are dividing, so be it, right? Distribute to every single thing on top, and every single thing on bottom. Okay, on this case, which rule can we apply? I have a variable on the top and on the bottom. That means that I can go ahead and use the first rule, the product rule, which says that when you divide variables, excuse me, the second rule, when you divide variables, right, you have to subtract exponents. So top minus bottom on the exponents. So that's 4x to the power of 2. 4x to the power of 2. You can see why the 4 is independent, right? The 4 is one item, and then this x is another item, and there's also an x on the bottom. So I can go ahead and divide the x's. Okay, x8 minus x minus 6, x8 minus 6, which is the same thing as x to the power of 8 divided by x to the power of 6. Okay, same thing. I have two variables. The rule says if I have two variables, subtract exponents, top minus bottom, 6 minus 8. So answer is x to the power of negative 2. Once you have a negative exponent, what do you have to do? Send it to the other side of the fraction. So this is on the top. I'm going to send it to the bottom of the fraction. That should be my result. Okay, remember that this applies only for variables with exponents, not for negative numbers, negative big numbers. Okay. Let's take this example. Okay, negative 30 divided by, negative 30x to the power of 13 divided by 5x to the power of 8. Numbers divide normally. Negative 30 divided by 5 is negative 6, normal division of numbers. Okay, they're big numbers. And then I have the variables that have exponents. This is where I apply the rule. Division of variables means subtraction of exponents, top minus bottom. Okay, negative 6, x to the power of 5. Okay, x to the power of 5. Let me see if I can get just so we can finish. Let's see if I can get a complicated one over here. I don't really have anything that complicated. Let's take a look at this one, just to finish up the lecture. Okay. Again, normal numbers, they behave normally. Okay, normal numbers, they don't follow these rules. Okay, so if I am dividing negative 2 by negative 7, let's take it even to an extra step. If I'm dividing two negative signs, a negative by a negative, I know that the result is going to be positive. So I can also say that those negative signs cancel out. Okay, I have a negative on the top, I have a negative on the bottom. Just like these two n's are going to cancel out. Okay, just like these two y's are going to cancel out. Okay, I'm not going to cancel out the y's. I'm going to show you the rule. I'm going to reach the same result using this rule because we are really used to saying those are, you know, y divided by y cancels out, n divided by n cancels out, but why do those cancel out, right? So let's go ahead and use the rules that we're doing right now. So a negative divided by a negative, that's a positive. So what I'm going to do is I'm going to keep those numbers. Since dividing 2 over 7 is going to give me a decimal, I don't want to get it more complicated than it is, okay? And then I have y's, y divided by a y. The rule says if you're dividing y by y, you have to subtract those exponents, right? So let me go ahead and get rid of this real quick. And so y to the power of, what's the exponent on the top? 1. And the exponent on the bottom is 1. Okay. To m to the power of 5 divided by m to the power of 8, the same thing. Top minus bottom. And then n divided by n, top minus bottom. And we keep going, right? We have 2 over 7, y to the power of 0, m to the power of negative 3, n to the power of 0. And this is where the rule of the zero exponent rule applies. Okay, anything to the power of 0 is going to cancel out, is going to cancel out. Okay, and anything with a negative exponent, right now it's on the top, is going to go to the other side of the fraction, is going to go to the bottom. Okay, so if I have my fraction, I have a 2 on the top, I have a 7 on the bottom, and I originally have an m to the power of negative 3 on the top. I am going to send it to the bottom, and that is going to make that m a positive exponent. So this will be the number that we're looking for, okay, or the expression that we're looking for. Okay. I'm gonna end up the recording right now, so I'm gonna thank you for attending this workshop right now, and I'm just gonna stay a little bit for if you guys have any questions. Okay, so let me go ahead and stop the recording. Thank you very much.